Now let us look the fifth example. Fifth example has two parts, A and B. Part A states that what volume of oxygen measured at STP will be produced during electrolysis by a current of 5 ampere supplied for 30 minutes. Part B, which current will be able to produce 2 decimeter cubic of chlorine by electrolysis at STP within 1 hour. We are given that the molar mass, we are given that the relative atomic mass of hydrogen is 1, relative atomic mass of oxygen is 16, relative atomic mass of chlorine is 35.5, molar volume at STP is 22.4 decimeter cubic, and 1 Faraday is equal to 96,500 coulomb. Now, let us start looking at the solution of this question by starting with part A. Now, let us start with part A. Solution for the question, part A. Part A, let us see the data given. Data given in example 5, part A, we are given electric current. We are given current electricity I. The current electricity given is 5 ampere. We are given is equal to 5 ampere. Also, we are given the time, 30 minutes. Time T is equal to 30 minutes. 30 minutes in 2 seconds will be equal to 30 times 60 seconds, which will be equal to 1800 seconds. So we have 1800 seconds. This is the time we have, but we are asked to use these two data to find the volume of oxygen at STP. The volume of oxygen at STP. Here, let us write the balanced chemical equation for this electrolysis. And as we are told that the oxygen gas was produced, it means that it was the electrolysis of hydroxide which takes place at anode. Now let us see the reaction at anode that involves the discharge of hydroxide to form water and oxygen gas. Let us see the reaction at anode. This reaction at anode involved the discharge. This reaction at anode involved the oxidation of hydroxide to form water and oxygen gas. As we are told that oxygen gas was one among the products produced. So let us see. It is hydroxyl ion. It was oxidized to form water and oxygen gas. With 4 electrons. To mean that it lost 4 electrons to form water and oxygen gas. This is the balanced chemical equation. Now, from this is aqueous. From this balanced chemical equation, we can use the mole concept to relate the number of electrons, the number of moles of electrons, and the oxygen produced. As you can see, we have 4 moles of electrons. 4 moles of electrons is equivalent to 1 mole of oxygen gas. So we say that from the balanced chemical equation, 4 moles of electrons are equivalent to 1 mole of oxygen gas. Now, from there, we can relate number of moles and the number of Faradays. As we know, 1 mole is equivalent to 1 Faraday. Now, it will be 4 Faradays are equivalent to 1 mole. 1 mole of a gas at STP has 22.4 decimeter cubic. So here, as we have 1 mole, it means that it will be 4 Faradays will be equivalent to 22.2 dm cube of oxygen gas. Now, if it would be maybe 2 moles, we would take 2 times 22. It is 22.4. we would, if we do, it would be maybe 2 moles of oxygen gas. It would take, to get the total volume, it would be 2 times 22.4. But as we are given only one more, we take direct as it is 22.4 decimeter cubic. Now let us change these Faradays into coulombs, into charge, so as to compare it with the data we have. Here we will have 4 times 96,500 coulomb will be equivalent to 22.4 decimeter cubic of oxygen. As you can see, I have multiplied 4 times 96,500 coulomb because 1 Faraday is equal to 96,500 coulomb, is equivalent to 22.4 decimeter cubic of oxygen gas. Now, if this is according to the balanced chemical equation. Now let's relate these values with the given values from the question. From the question, we have time of 1,800 seconds and current of 5 ampere. Now, when we take the product of these two, we get the charge, the total charge from the question. Now, the part of the charge is the left-hand side. So, to get the charge according to the current we have and the time we have, we take the product. So, it is current times time. It is 5 times 1,800. 800. These are coulombs. These are equivalent to the expected amount of oxygen to be produced, which is in terms of volume, and it is what we are solving for. So we are looking for the volume of oxygen gas at STP, which will be produced when we apply the current of 5 ampere in 30 minutes. Now, let us see that volume. Let us rate maybe the volume to be X. Let us rate the volume of oxygen gas which will be produced when we apply this amount of current within 30 minutes be X. Now, to get it, let us cross multiplication. We're going to cross multiplication. When we cross multiplication, to mean that this value will be multiplied by X and this value will be multiplied by 22.4. So what it comes here, we're going to have 4 times 96,500 times X is equal to, will be equal to 5 times 1,800, 5 times 1,800 times 22.4 times 22.4. After there, let us multiply. Let us use a calculator to multiply the values on the left hand side and the right hand side. On the left hand side, you have 4 times 96,500. Yes, here we get 386,000 X will be equal to 5 times 1,800 times 22.4. Here we are going to have 201,600. 201,600, as you can see. Now, from there, to get X, we have to divide by 386,000 both sides. Now, let us do it. We are going to have 386,000 X is equal to 201,600. So let us divide by 386,000 both sides, so as to get X. 386,000 both sides, so as to get X. Now X will be equal to 201,600 over 386,000. As these are equal, they cancel out, so we remain on the right hand side, we are remaining with the X only. Now let us see the value we get. That one over 386,000 where we get is equal to 0.52. This is in terms of decimeter cubic. So we say now the volume of oxygen gas of oxygen gas produced at STP will be 0.52 decimeter cubic. Now this is the solution for part A. For example 5, part A, this is the solution. The volume of oxygen gas that will be produced is equal to 0.52 decimeter cubic. Now, after the solution for part A, let us see the solution for part B. Part B, let us analyze data given for part B. Part B, as you see, we have the volume produced, volume of chlorine produced. We have volume of chlorine produced. Volume chlorine produced is equal to the volume of chlorine produced, the volume V of chlorine. Let us say the volume of chlorine produced. Volume of chlorine produced is equal to, we are given it is 2 decimeter cubic. 2 decimeter cubic. This is the volume of chlorine produced. Also, what are we given? We're given also the time t. Time t is equal to 1 hour. To 1 hour, which is equal to 1 times 60 seconds. As you know, 1 hour is equal to 60 minutes. 60 minutes to change it into 2 seconds, we multiply again by 60. So 60 times 60, we get 3,000. We get 3,600 seconds. Now this is the time given, 3,600 seconds. Another data required here is current electricity, and in this question we are asked to calculate the current electricity required. So current electricity I is required. This is the required value. So we are required to calculate the amount of electric current required for this electrolysis to take place. Now here, the same, we are going to use a balanced chemical equation, and you see it is the electrolysis of chlorine. If it is the electrolysis of chloride ion to produce chlorine gas, it means that it is an oxidation reaction which takes place at anode. So here let us see the reaction at anode. Reaction at anode. Reaction at anode. As usual at anode, chloride ion is going to be oxidized to form chlorine gas. Now, chloride ion is going to be oxidized to form chlorine gas. As you see, chlorine gas, as you see, 2 ions will require 2 electrons. Here, after that, we are going to use this balanced chemical equation and to relate with the mole concept. Now, we are going to relate the number of moles of electrons required and the number of moles of chlorine gas produced. Now, from this equation, it shows that 2 moles of electrons are equivalent to 1 mole of chlorine gas. 1 mole of chlorine gas, as you see. If so, let us convert directly this number of moles of electrons to Faradays. 1 Faraday is equal to 1 mole of electrons. So these 2 moles of electrons will be equal to 2 Faradays. Now 2 Faradays will be equivalent to 1 mole of chlorine gas. When we change 1 mole of chlorine gas at STP, it will be equal to 22.4 decimeter cubic of chlorine gas. Now, here, let us convert Faradays into coulombs, to charge. It will be 2 times 96,500 coulombs. Coulombs will be equivalent to 22.4 decimeter cubic of chlorine gas. I have multiplied 2 by 96,500 to get the total amount of charge, because 1 Faradays is equal to 96,500 coulombs. Now, after that, these are the value from the standard balanced chemical equation. Now let's relate them with the values from the given equation. From the given equation, we are given 1 hour, which is equal to 3,600 seconds. Also, we are given the volume produced, the volume of chlorine gas produced is 2 decimeter cubic. Now it means that on the part of volume where 2 decimeter cubic of chlorine gas are equivalent to the amount of electric current produced times its time to get the charge. So the amount of current is not known. It is what we are looking for, I times time is 3,600 seconds. So here we will be in the position of being capable to find the value of I, which is the current. To get it, let us cross multiplication. When we cross multiplication, we take I times 300, we take I times 3,600 seconds times 22.4 decimeter cubic will be equal to 2 times 2 times 96,500, 2 times 2, I mean this 2 times 2 times 96,500 coulombs. Now here, let us multiply. Let us take the values on left hand side and right hand side. On left hand side we have 3,600 times 22.4. Here we get 80,640 times I is equal to 2. On the right hand side we have 2 times 2 times 96,500. So here we get 386,000. Now, what next is to divide by 80,600 both sides, is to divide by 80,640 both sides so as to get I. Now here we have 80,640 I is equal to 886,000. We divide by 8,640. 8,640 both sides. Here we are remaining with the I. I will be equal to, when we divide this value, we get over 8,640. We get 4.786, 4.7867, which is approximately, is this ampere, which is approximately to 4.8 ampere. This will be the current. This will be the current. Now we say the current, the amount of current electricity, the amount of current electricity, to be applied, to be used, will be 4.8 ampere. 4.8 ampere. And this is the answer. This is the answer for this, for example 5, part B. For example 5, part B. Example 5, part B, the answer is 4.8 ampere. Now, this is the end of my presentation on the Faraday's Festival of Electrolysis. I hope you have understood well, because I have used many examples. Via all 5 examples, I am sure that you have understood well. Thank you for attending this session. Have a nice moment. Bye.